Hi and welcome to this video about how to draw force diagrams. Sometimes you'll also see them referred to as free body diagrams or FBD. So if you see free body diagrams or you see just force diagrams, they mean the same thing. So here's steps 1 to 6 here of to how to do the force diagrams. One thing I'm going to mention is, and maybe I'm not sure what we've done in class yet, depending on the year, but Newton's first law essentially is if something is moving in constant velocity, then the forces are going to be balanced, and if it's accelerated, they're going to be unbalanced. So that's one way to look at our forces. So let's do our first one here. It says a book is lying motionless on a table. The classic book on a table here. I'm just going to keep on drawing things. So here's the earth, here's the table. I'll give the table a little bit of depth here. Here's the table. And this is the book over here. So, here's air in the room. We can have lots of things. So if we look at this, first of all, it says sketch the system and its surroundings. Yeah, we've definitely done that. Enclose the system with a system boundary. So here I'm going to try to narrow this down to say, what's actually involved in this situation. What we want to do is we want to draw the book. We want to draw what are the forces acting on the book. We're not worried about the forces acting on the table. We want to only do the forces acting on the book. So here, I'll get rid of the air. So I put a box around the book. Okay, so I've done that. That's my system. Shrink the system to a point at the center of coordinate axis with one axis parallel to the direction of motion. Okay, well, it's a little bit tough because I'll shrink the book to a dot. So there's the dot. And now if I'm going to add the axes, it's not moving. But if I was to pick axes, and if it was to move, perhaps it'd be on the familiar horizontal and vertical. So it doesn't quite pick, it doesn't follow exactly because there's no motion. So in this case, I'm just going to do X and Y. Represent all relevant forces across the system boundary with a labeled vector. Okay, so what are the forces acting on the book? There is going to be, well, the Earth is interacting with the book, isn't it? So there's a force of gravity downwards. And I'm going to write my on-by statement. Force of gravity on the book by the Earth. Is there any other force acting on it? Well, if I look at this, there's this table that's interacting with the book. So I'm going to draw that one, and the table is pushing back upwards on the book. So there's going to be this one. There will be a normal force on book by the table. Cool, got it. Now it says, indicate which forces, if any, are equal in magnitude to other forces. So the way I do that is by having these equality. If I have the same number of ticks or circles or symbols on each one, that means that those two are equal. All right. Indicate which are equal. Did it use on by when naming the forces? Oh, I did that as well. Okay, so that looks great. That's what the first one would look like. Let's try the second one. It says someone removes the table and the book starts falling. So here is my book again. The table is gone. So there's the book. Here's the Earth down here. There's no table anymore. So here's my system. I want to do the book. So shrink the book to a dot, and I'm going to draw my coordinates here. Now I do have some motion because it's going to start falling. It's going to go, I don't know, it's going to, if I did a motion map, it would start falling and it kind of look like this, right? And the motion that it would have would be this downwards motion here, like that. That's the motion. So one of my axes is going to be that vertical motion, and the other one will be perpendicular too. So I've got my axis there, and I will draw my force. I've got this force of gravity. Picked a big pen. Let's pick a smaller pen. Force of gravity on the book by the Earth. There is no table pushing back up on it, so that's the only one we have. Moving on to the next page. A car, instead of car, because it's hard to draw, I'm going to say a block. I don't know, a piece of wood or something. So, here's my block. It is coasting right it's moving right and slowing down. So again, if I was to draw a motion map for this, kind of like this is what it looks like, and I've got this, these arrows are getting shorter as we go by. Okay, so we've got the block, and I don't know what this is. Could we have it as maybe a table or something that's sliding on? And of course, this whole thing, we've also got the earth underneath. Wouldn't necessarily have to draw all this, but and now the thing that I'm worried about or interested in, my system, is just the block. So we'll go like this, and definitely one motion will be this way, horizontally, because that's the way that it's moving. So a little snapshot of the block. Now what are the forces that are acting on it? Well, we're going to have a force of gravity downwards on the block by the earth. The table is pushing up on it. We're going to have the force normal, perpendicular, on the block by the table. Is there any other force that's acting on it? Well, there's a friction force, because if it's sliding to the right, and we have we have a parallel force, which way would the friction be acting on it? Well, if it's moving to the right, the friction is what's going to sort of oppose that motion, and so the friction force is going to be to the left. Okay, friction force on the block. Here, I'm going to erase some things so I have some more space here. On the block by table. So you'll notice, first of all, I think you're getting to see the pattern. This on is pretty easy. It's always on the same object. It's the object that is represented by that dot. And the other thing that's interesting is this table business. It's both the normal force and the friction is by the table. There's two different directions. The normal force is perpendicular to the surface. So here's here's the surface that's interacting. So the normal force is going to be perpendicular to that one, or if I redraw it from the center, it's going to be that way. And the friction is parallel. So here's the surface and here's the friction force. So one's perpendicular and one is parallel in this case. Now, are there any that are equal? Well, you'll notice that what did we have back here on my description? I said, if constant velocity, then forces are balanced. So this one's balanced. Those forces would cancel each other out. That's what balance looked like. If accelerating, then unbalanced. Oh, here's an example. This is not balanced because this is only going downwards. So, not balanced, because it's accelerating downwards, and you can see this velocity is changing. In this example, we have this velocity. The velocity is changing, so this is going to be not balanced. So in other words, all these forces are not going to be balanced. They're not going to be canceling each other out. Now, which way is it accelerating? And it's actually accelerating. It's a little bit hard, but the acceleration, if I did these acceleration dots, the acceleration would be to the left. It's going to the right and slowing down, and you can see these arrows are getting shorter. So that's the direction that we would have the unbalanced force. There's no acceleration vertically, so these two forces are going to cancel each other out, and we have that other force of friction left. And even though I may have drawn the arrow about the same length, we don't know anything about whether that force of friction is greater or less than either the normal force or the force of gravity. Okay, the next one says a ball is moving upward after it has been thrown. So here's my ball. If I was to do a little bit of a motion map, so it's moving up fast and it's going to be slowing down as it goes up, right? So, again, we could say, oh, think about this. We got these velocity is going up. Those are V for velocity. And I could even draw another set of motion of ones here, and I could say, well, which way is it accelerating? How is it going to... Okay, it looks good. It's accelerating downwards the entire time. Okay, so there's the ball, and I guess the only other thing with the surroundings is we also have an earth. So when I draw my free body diagram or my force diagram, there's my dot for my ball. Looks very much like a smaller version of the dot. The only force I have acting on it is the force of gravity on the ball by the Earth. And so you'll see again that the direction of the acceleration was the same as the direction of the force. Mr. Speiser pulls his son on a sled at constant velocity. Okay, this is a little bit tough to draw, so I'm going to draw, here is a sled, and oh boy. Okay, so here's my really bad diagram of my son, and I'm going to say, pulls his son, I'm going to say with a rope. So what do we all have here? We've got a rope. We've got the sun and the sled, and we've got the earth here, and we've got the, I don't know, the snow surface. How about this is the sidewalk here? Okay, so what is the pick a color here. Pick green. What is the object that we're going to say? Well, I think instead of just using only my sun, I'm going to say that the object that we're interested in this case would be the sun and sled. Okay, so here's the sun and the sled. So what are all the forces and objects involved here? Well, I've got this rope pulling to the right, so this is going to be a tension force. Okay, on, how would I name this object? Sun sled. Sun and sled by the rope. I'm going to have a force of gravity downwards on the sun slash sled by the earth. I'm going to have, now we've got this contact between the sled and the sidewalk, so perpendicular to that contact, I'm going to have a normal force, a perpendicular force on sun slash sled by the sidewalk. And there's also, well, the question is, are we done? Well, the key here is it says at constant velocity. So if it is constant velocity, that means that my acceleration is going to be equal to 0, and I'm going to have balanced forces. So if the forces are balanced, then I got to make them balanced. So they're not balanced right now. So I need to have a force that goes this direction. What would that be? And I think you may know, that would be friction. So I have the force of friction on the sun slash sled by the sidewalk. In terms of which ones would be equal, these two would be equal, and these two are equal.